Welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll continue learning about pre-processing in Scikit-learn. Especially, we'll talk about encoding categorical features. We'll begin with what they are and why there is a need to encode them, and then we'll also look at what are ordered categories. And finally, I'll show a code snippet on that gives a general quick intuition about how to implement this before we get into Jupyter Notebook to do the actual coding. So, what are categorical features? If we look at this table on the left hand side, we have three columns: city, population, and size. Of these three, only the population column is numeric, others two have words in them. Now, each of these columns, city and size, can be converted into categorical columns. So, therefore, we can consider these as categories, and we can also call them as categorical features. So, what are the categories within city? Within city, we have the values are sun mark, sky shadow, apple land, and geoterrain. So those are the values for the category city, and then for the size, we have small, medium, and large. Now, why there is a need to encode them? The reason is because for machine learning models, we need the input data to be numeric. And because it has to be numeric, we need to convert these words into numbers. And one way to do that is as shown here. What we can do is create a new table, and then for each row, for example, if you look at the first row, we can put a value of 1 if that particular value exists in that row. Else we put the value as 0. For example, here we have all 4 names of cities, and of these 4 names in the first row, we just have the sun mark present. All others are absent. So therefore, we put zeros in case of all other columns. Similarly, the size is medium, so we put 1 for medium and then zeros for small and large. And the numeric column stays as is. Similarly, if we look at the last row, we have geoterrain. So we put 1 for geoterrain, and then we put zeros for all other cities. And the size is large, so we put 1 for large, and then we put 0 for other all other values, small and medium. So this is one way to encode the categorical features, uh, so that it's now all numeric. Now, what are ordered categories? Ordered categories, unlike the previous case where we had small, medium, and large, they were as separate columns. Here we can arrange them and put an order to them. So we can say that large is greater than medium is greater than small, and then assign them values 0, 1, and 2. So for the size, then for the first row, we have the size as medium. So instead of zeros and ones, here we can put a value of 1. And then for large, we can put a value of 0 because it's the first one as we have denoted here. And then for small, we can put a value of 2. So here we have specified an order to the categories. So that's why they are called ordered categories. And we'll look at the implementation of all of these in Jupyter Notebook. So for the code, we want to import NumPy, and from sklearn, we want to import the pre-processing library. And this is sample data that we have, where first column is one category, second column is second category, and third column is third category. So cat and dog, then we have meow and bark, and then small and big. Now this is one way to encode, which is using OrdinalEncoder, which considers the categories to be ordered, and therefore it's called OrdinalEncoder. And to write the code, you would initialize enc here by typing preprocessing.ordinalcoder, and then fit that to x, and then transform any value that you are looking to transform. And similar to this, there is another method which is OneHotEncoder. It works the same way. First, you want to initialize, then fit, and then transform. So, looking at the previous slides, if you go back, this particular method would be ordinal because we are putting an order to the categories, whereas this particular method where the values do not have any order, categories do not have any orders, those would be one hot encoding. So in this particular plot, this cities part is one hot encoded, whereas the size part is ordinally encoded. Now let's get into Jupyter Notebook and start coding. Here I've imported the libraries as shown earlier, and for these are the versions that I'm using. Now for data, these are sets that I've already created. I'll put them in the description so you can copy paste them in your notebook. So let's go ahead and run these. Now the first item that we'll look at is ordinal encoder. So ordinal encoder. And for ordinal encoder, there is an option for using auto encoder. So we'll look at that first and then we'll move on to where we can specify the order ourselves. So for this, we'll use this data. We have game. Now, first we'll initialize the variable enc is equal to preprocessing dot ordinal encoder, and here we'll specify categories is equal to auto. Even if you do not type this, it's okay. And enc dot fit, and here we fit it to the game. So once we are done with the fit, we can now use it to transform. So enc dot transform, and then within this we can specify the new data that we want to transform. So let's say second, silver, bottom, and then we have another list here. Let's say first, bronze, and top. So when we run this, we see that these now have been coded such that they are ordered categories. So we can check the categories enc dot categories, and these are the categories that we have. So if you notice, first, gold, and top, so first, second, and third. So first, second, and third, they are in this order because they are in alphabetically F, S, and T. Those follow that sequence. However, if we look at the second one, gold, silver, and bronze, they do not follow that order. So they are switched. Bronze comes first, gold comes second, and silver comes last. So the reason why that is because B comes before G and S. So that's sorted out in alphabetical order. And that's when we have categories set to auto. And looking at this order, let's see how these numbers work. So if we look at the very first column, we have second here, and in this particular set we have first. So first, and then we have second. So second has a value of 2. So 0 1. So second has a value of 1, and therefore we have this 1 here. Then looking at silver has a value of 0 1 and 2, so we have 2. Then bottom has a value of 1 because it is the first one. Sorry, it has value of 0 because it is the first one, and therefore we have 0 here. So the numbers start with 0. Similarly for the second row, we have first written here. So first has a value of 0, so we have 0 in the output. Bronze has a value of 0 again because it is the first one in the category, and therefore we have a 0 here. And the top has a value of 2 because it is the last one, and therefore we have 2 here. So that's how the categories are ordered. Now we could go ahead and arrange these in a specific order. So let's say, let's call this categories. And here we are going to manually order these categories. So we had winner is equal to, we have first, second, and third. Now, so that's the order we want to keep. And then for medals, we have gold, silver, and then we have the last one we had was bronze. So those are the orders for medal. And then finally we have ranks. For ranks, we have the top, then we have middle and bottom. So these are the orders that we would like to maintain. So the way to make that work is we initialize enc again, pre-processing dot ordinal encoder categories, and within categories we can specify the list of all the categories we have sorted above. So winner, medal, and ranks. So once we have these, we can fit it. So enc.fit, again we fit it to the same data set. Sorry, winner, that's my mistake. So these are the ordered categories we have. Now if we go ahead and transform the same data set, as we see here, this time we get a different output as compared to what we had earlier. And the way this works now is second is 0 1, so we have second is 1. Then for silver we have 0 1, so therefore we have a 1 here. Then for bottom we have 0 1 2, and therefore we have a 2 here. Similarly for the second row we have first, which is 0, and therefore we have 0 here. For bronze, bronze is the last one, so 2, and the top is the first one right here, so we have a 0 right here. So that's how the ordinal encoding works. Now let's move on to look at how OneHotEncoder works. So OneHotEncoder, and what OneHot means is if that value is present in the row for that category, then it's flagged as 1, else it's flagged as 0. So for this particular case, we'll use the data that is X, and the method is the same. We start with initializing enc is equal to preprocessing dot one hot encoder, and again we use the same method. We want to fit it to X that we have above, and once this is fit, we can now transform a data set of that we want to transform. So let's create one. So enc.transform, and here I'm going to create football. So football, and then we have bat, court, and then after this let's create another one. We have cricket, so sports, and then we have shoes and net, and finally for the last one let's create again another football, and we can create bat and net. So when we transform this, we get this output which is object. Now to get the numbers we need to type dot to array at the end of that line. So this is the one hot encoded matrix that we have, and as you can see the only values in here are either zeros or ones, and that's what one hot encoding means. So the way this is arranged is as follows. We can go ahead and look at the categories. So enc dot categories, and here we can see the categories. So they follow this order. So first this row, then this row, and lastly we have these. So 1 2 3 4 4, and so these are 12 columns right here, one for each of the categories or values that we have in the data on which we had run the fit. So the first one is basketball. So in the data which we transformed, there is no basketball, so therefore we have zeros in all the three rows. Then the second one is cricket. So we do have a cricket in the second row, and only in the second row. So only second row has one, the other two have zeros in them. Then third one is football. So football is present in first and the third row. So therefore we have first and the third row has one, the second row has a zero, and so on and so forth. So let's look at the last one. For pitch, we do not have that anywhere in this data set in the last column. So all the three rows have the value as zero. Whereas if we look at net is present in the last two rows, therefore we should see 1 for last two rows and 0 for the other one. So we have 1 here, and then we have a 0. So that's one way to perform one hot encoding of a given categorical data. Moving on, now let's look at another way in which we can uh, do one hot encoding, where we can specify the categories separately. So let's try that. I'll put number 2 there, and for this we'll create variables such as sport, and for sport we'll put the names here. So let's say basketball, and then we have cricket, football, and tennis. And after this, let's put gear is equal to, we have a band, and then we have bat, helmet, and then shoes. And lastly, we'll put a location, and for this we'll have court, ground, followed by net and pitch. So these are the variable names that store the categories. So we can again go ahead and initialize enc is equal to pre-processing dot one hot encoder, and here we can specify the categories. So let's say these are the variable names, so sport, gear, and location. So once we have this, we can go ahead and fit this to data that we have. So let's use G. So let's go ahead, check what names we have given. So here we are calling this X. So let's go ahead and use X as the name. Let's see, X. Yep, that should work. So I'm going to go ahead and use X right here. And if we go ahead and do enc.fit x, this is now fit to X dataset, and we can now use that to transform. So enc.transform, and now we can specify what we need to transform. So here we'll create another set. Let's say cricket, bat, court, and next one, let's say basketball, helmet, and let's create ground. So now when we need to put 2 array at the end of this, and as you can see, we have one hot encoded these 2 lists that we had by using enc.transform, and the values work the same way as we saw before. So if you look at enc.categories underscore and look at this, so we have basketball, which is the first category. So basketball is present in the second row, and therefore we have a 1 there and a 0 on top, and so on and so forth. If we go to, let's say, ground is the third row from the last, so 0 1, so 1 2 3, this particular row, and we have ground only in the second row, so we have a 1 there, and the first row does not have ground, therefore we have a 0 there. So that's another way in which we can uh, mention categories to the one hot encoder when we are initializing it. Next, what happens if we have some categories in this particular transform set that are not present in the fit set? So there is a provision in OneHotEncoder called ignore, and that can be used to ignore such new categories that are not present. So let's look at let's initialize again. enc is equal to preprocessing dot one hot encoder, and here we'll specify handle unknown is unknown is equal to ignore. And what this does is, now when we do enc.fit and x, what this will do is if we add a new category right here, it won't throw an error. So let's say here if we put a new category, let's say a train, and we know that train is nowhere there in these categories that we have created earlier. So this would uh, throw an error if ignore was not present. So let me go ahead and delete this. So if I run this, and so as you can see, found unknown categories train. So to avoid this error, what we can do is type in handle underscore underscore unknown is equal to ignore, and when we fit using that, then that particular column is ignored and we get this output. So the train category is ignored and we get the output for other categories that are present in the uh, categories that were fit. Moving on, now let's look at what happens if we have uh, binary categories and how do we handle those. So sorry, so let's go ahead and get this. For this one, we'll use this data set, and here male and female. So the first column, that's the binary category. So if it's male, it can be male or female in this case. So we'll create a variable to initialize, which is drop underscore enc is equal to pre processing dot one hot encoder, and drop is equal to if underscore binary. And the reason why we want to specify this, now if we say drop underscore enc dot fit h, so you could type it like this, or you could simply say this is fine, and the equivalent way of writing this is just typing fit underscore fit h. So that's fine too. Now what this will do is it will create a column only for either male or female but not both. So let's try that. If you look at drop underscore enc dot categories underscore, these are the categories we have. Now if we transform h, so drop underscore enc dot transform h, and here we specify two array. Now we can see that total we had 1 2 3 4 5 6 7 8 categories, but the number of columns that we have are only 7. And the reason is because one of these two categories is dropped, and the reason why that is dropped is because in some machine learning models, if you have a matrix such as this one, which has two columns that are collinear, as in they are related to each other, correlated, then that creates problems when you are trying to calculate the inverse of a matrix, and therefore it's important to drop that one of those columns that are similar or related. So here we can see that if we look at the very first value, it's male and male in the two, and therefore we have 1 and 1 here, and we do not have male in the second row, and therefore we have a 0 there, right here. And similar, so what it tells us is that the column for female is dropped. And if we look at the second column here, we have truck, car, and bike. So let's look here. For this, we have bike is present in the third. Okay. So if we look here for the second, this column, we have bike only in the third row, and therefore we have by 1 here. Next, we have car. So car is only in the second row, so we have 1 here, and truck is only in the first row, so that's why we have 1 here, and rest of them are 0, and so on for the rest of the columns. So that's one way to know, one way to remove binary category, part of the binary category. And next, let's look at another way where we can use values from a dictionary to create such categorical values. So for that, we need to import a library. So from Scikit-learn, scikit-learn.feature, feature extract, feature underscore extraction, import DictVectorizer. So here we'll use the data set that we created, plants, and what we have key value pairs. So we have fruit, and the value is for that is pair, and then we have weight, and the value for that is 178. So that's list of dictionaries. So that's one dictionary, and then we have a second dictionary, and so on for the data. Here we can initialize this variable vec is equal to dict vectorizer, and then we can fit this. So vec dot fit underscore transform. We can do fit and transforms in separate steps, or we can combine them using fit underscore transform. Both of them are fine. So here we are using fit underscore transform, and we'll use the data set plants, and then specify to array. Now when we run this, what we have is we have OneHotEncoded the values for fruit, whereas these numeric values for weights remain as is, as we can see 178, 250, and 5. But for these pear, pomegranate, and cherry, we have encoded them. So let's see if we can see the feature names, feature underscore names. So these are the attributes, feature underscore names. Okay, so cherry, pear, pomegranate. So first one would be cherry, and here we can see that cherry is present only in the third 0, 1, 2, and third dictionary. So therefore we have third row, which is 1. All other top 2 are 0. And similarly for pear is in the first one. So we have first row that is 1, and the other 2 are 0. And finally for pomegranate, we have that in the second row, and the other 2 are 0. So that's how we can go ahead and do one-hot encoding of categorical values that are present in dictionaries. Now, before we end this video, I just wanted to show you what I meant by inversion of matrix. So let's say we have a matrix. Let's create a matrix here, array, and it has values, let's say 1, and then 23, and 10. And then we'll try to create the first and this first and the third column that are collinear. So let's give some random value here, and then this will be 20, and then again we give another value here, and then give some random value here, and then call this 30. So as you can see, in this case, in this particular data, we have the first column increasing 1, 2, and 3, and the last one is also increasing 10, 20, and 30. So they are correlated. Now, if we try to calculate the determinant of this, so if you type linear algebra library we need, and if you calculate determinant of x, we get a value that is very close to 0. So let's do this. So because we get the value of determinant equal to 0, these two are correlated, and therefore we need to drop one of these. That was it for this video. I hope in this video you learn what are categories, what are ordered categories, and then what is ordinal encoding, and then what is one hot encoding. We also looked at a couple of examples where we can specify a set of categories, how we can drop unknown categories, and how we can drop one of the categories if it's a binary category. So in next video, we'll continue learning more about pre-processing in Scikit-learn. If you have any comments and suggestions, please let me know in the comments below. I hope to see you all in the next video. Please like, share, and subscribe. Thank you.